now. All right, so what we're looking at is chapter 8. And in particular, we're looking at chapter 8 worksheet, or the first thing that comes up on chapter 8. It's a Word document, and it's talking about net present value and internal rate of return. Now, before I get started, I just want to give you a little background. I'm going to go ahead and you see a blank sheet of paper. And it seems like I can draw on this a little bit better than some of the others. All right, so what we're looking at is basically what's called capital budgeting. And in reality, capital budgeting is probably the most important thing that we'll cover for non-finance majors. So this is the most important thing that we'll probably talk about from this class, if you're a non-finance major. Now, some of the other things we've talked about, you need to know. And remember, we require you to take this course because society or someone has demonstrated that if you are a business major, you have to know something about financial management. And so far, we've started talking about stocks and bonds. And in reality, that's good for you to know on more of a personal level. Okay. When it comes to working and so forth, this is probably the most important topic that we cover in the class, because basically it goes through and says, hey, if you're working for a business, the goal of the business is to maximize shareholder wealth. I mean, unless you're in a not-for-profit or some other service business. But for most businesses, they're wanting to figure out how to make additional profits. And everyone's wanting to grow. We saw that even with stocks and stock prices. Everyone's looking at how we can grow the company's earnings or net income. And there's really two ways that you can grow net income, and we'll cover both of these. Now, we're not going to do it all in one chapter. There's probably 3 or 4 chapters is what this entails. And we'll look at different pieces of it in each chapter. So you got to kind of start somewhere. So one of the things we look at is, how do we increase net income? Okay. And if we look at in other words, how do we grow the dividends, and how does the stock or the value of the company become more profitable or more valuable? And so we're interested in net income, and net income we can kind of see from the income statement is revenues minus costs. And yes, there's interest and taxes and other things. Yeah. But again, the way you can grow net income is to either come up with new products or new ideas and increase revenues, yeah, or the other way is to decrease costs. So we'll look at 2 different types of projects eventually, not in this chapter, but in later chapters. And we'll look at what are called expansion projects. And expansion projects are basically ways in which we can increase revenues. We can come up with new products that people will buy, new ideas. Okay. The other type of way to increase net income is to decrease costs. And not surprisingly, these are called cost-cutting projects. In a cost-cutting project, you're basically spending money today so that you can reduce costs in the future, and that will help increase your margins, whether it's gross margins or operating margins or net margins or some combination of all 3. Okay. So 2 types of projects we have are cost-cutting projects and expansion projects. Okay. And we'll look at those separately later on. Now, if you ever seen, or some of you may do this in class, I don't know, I've kind of seen it on TV somewhere, and the people sit around and have some sort of brainstorming session. Hey, what can we figure out to do to become more profitable? We need new ideas. Yeah. And they sit around and 4 or 5 people pitch their ideas, and they try to figure out which one is the better one. Okay. What we're going to learn here is a way to analyze financially different ideas. So a lot of times what you'll have is what are called mutually exclusive projects. And that's not spelled right. Mutually exclusive projects. And what that means is that you may have 1, 2, 3, 4 different ideas. Okay. And these ideas may be different. Okay. One may last for 2 years, one might last for 3 years. Okay. And one might last for 5 years. Okay. And what we want to do is go ahead and analyze these 3 different projects and sort of determine which one's the best idea. Okay. So we're going to need some tools to analyze this, and we're going to need some tools that are appropriate. And that's what we're learning about in this chapter. What are the tools? And so we're going to learn about net present value and internal rate of return and payback period. And these are some of the tools that we need to assess whether or not A is better than B, or B is better than C, or is C better than A. Yeah, we can look at these mutually exclusive projects and sort of rank them. And so we can get an idea about which projects are the most profitable. And essentially what we're going to do is use something you're familiar with. It's called a cost benefit analysis. Okay. But this net present value is a more formalized cost benefit analysis process. So if we go ahead and look at something simple before we see a project, what if we could spend $100 today on some idea? Okay. And we go out and pitch this idea and say, hey, okay, and we may look for other investors if we don't want to use our own money. But if we spend $100 today, what happens if we expect to get back 115 a year from now? Does that seem like a good idea? Yeah. Well, if we knew for certainty we'd get back 115, it would kind of make sense. Now, we wouldn't necessarily make $15 on this, okay? Even though it looks like we're making $15. We're not really making $15, okay? Because we could have used that $100 and done something else with it. That's where we come up with something called an opportunity cost of capital. And if we look at that $100 and we could have put it in a bank account and maybe earned 2%, and at the end of the year we'd have $102. So we can kind of see, well, if in fact we spent 100 to get back 115, it looks like we're making $15, but we're not really making $15 because we could have done something with the $100, put it in a bank account. Okay? And if we put it in a bank account that pays 2%, now we can sort of see, well, we do still have a benefit, but the benefit now at the end gets reduced maybe to $13. Okay? But remember, the other thing we got to worry about is not only what's our expected cash flow in the future, but how volatile is the result. That is, how certain are we that we're going to get 115? We could be getting more, we could be getting less. So what we've got to figure out then is how to assess this future cash flow in terms of risk. Now, if this future cash flow came apart as the result of, say, some government contract that was guaranteed, then it would be fairly low risk. Okay? There might be some other variables that happen, but for the most part, if this was a government contract minus some kind of delays here or there, maybe that it's pretty low risk and that most of the time we'll get back 114, 115, or 116. So we call it an expected value of 115, but it's fairly low risk. If that's the case, then the appropriate discount rate would be lower. Yeah. Or it could be that this is something that's fairly speculative, and we could get back maybe $70 or $80 or $90 or 115 or 130 or 140 or maybe even 150. Okay? Now this expected value of 115 comes with a lot of risk. And if it has a lot of risk, okay, then we're going to have to choose a different discount rate, okay, to evaluate this. In fact, if it has a lot of risk and the appropriate discount rate was, say, 20%, yeah, and that our opportunity cost of capital was 20%, then if we took $100 and it earned 20% somewhere else, yeah, then we wouldn't want to spend it on this project because we could have earned 120 somewhere else, and this project's only giving us 115 on average with a lot of risk. So what we've got to decide before we even get into this is, what are the expected cash flows? What does the expected cash flow mean? And what's the appropriate discount rate to use? Okay. Now, in order to give you an example, I'm going to go ahead and pull up something else that's not on here. Just give me a second. All right, now I'm going to go ahead and share the screen in just a second, but before I do, let's go ahead and ask someone a question. All right, Kayla, you there, Kayla?
Yeah.
All right.
Oh man.
Kayla Younger or Kayla Bird. Sorry, I was looking at a different one. Kayla Younger, you're fine. You're there. All right. If I threw up 100 coins in the air, okay, what would you expect the number of tails to come up to be?
The expected?
Yeah, I throw up 100 coins in the air and I said, hey, how many tails do you expect to happen if you looked at the bottom and started counting?
50?
Yeah. And that's exactly what everyone says. Okay. Now, if you look at it, we can pull up what actually happens. Okay. So what actually happens when you throw up 100 coins is somewhere between 0 tails will occur and somewhere between 100 tails will occur. But most people say, hey, what's going to occur is that we'll have 50 tails come up. And 50 tails is the most likely outcome. It's 7.96%, or about 8% probability that that actually happens. What we really mean when we say 50 tails will come up if we throw the coins in the air, in fact, if we took the whole class and each of you had 100 pennies and threw them up, and I asked you to count how many tails you had in your pile of 100 coins that you threw up in the air, okay? Not very many would have exactly 50, okay? Only 8% of the class. So if we've got 40 people in the class, probably about 3 of you would have 50 tails and 50 heads, okay? About 3 of you would have 49, but 3 of you might have 51, okay? And so on and so forth. And we can actually develop a probability distribution of what we expect to happen. So even though we call this an expected outcome, and even if we write down, and we'll see in later chapters how we get the future cash flows. But if I'm saying, hey, I expect to have $115 next year, it's very unlikely that that's exactly what I mean, okay? Now, what Kayla probably could have said, although it would sound a little weird, is she could have said, hey, I expect 50 tails with a standard deviation of 5. What does that mean? Well, going back to our probability distributions, it means somewhere between 45 and 55 is what's likely to occur. And if we look back, try not to do too much. Oops. Okay. And if we look back to that tails question, okay. Kayla said she expects 50 tails, but really when you throw the coins up, we all know there could be more or less than 50. And in fact, if we knew the standard deviation, that is how much variation there is, standard deviation is just the square root of the variance. And if you remember from your stats class, plus or minus 1 standard deviation is where we expect things to occur about 68% of the time. So in this case, if the standard deviation is 5 in this throwing of the coins example, then if we threw the coins up, 50 is the number we said we expect, but we really mean it's probably going to fall most likely somewhere between 45 and 55. Okay? So an outcome that has risk, you need to know what the expected or average is plus some standard deviation. Okay? And if you wanted to be 95% certain, you'd give it a much wider outcome, plus or minus 2 standard deviations, which means if you wanted to be pretty sure you were correct, then Kayla could have said, hey, I'm about 95% certain that when I throw these 100 coins up, I'll have somewhere between 40 and 60 tails. Even though she said she expects 50, okay, in reality, 95% of the time when we throw those coins up, they'll be somewhere between 40 and 60. Now, just to give you another idea, okay, as we look at this, see if I can pull this back up. You may wonder, hey, what is the chance? What is the chance if I threw the 100 coins up that I would get all heads? That is, no tails. Okay? Now, when you throw the 100 coins up, there is a chance that you could have all the coins pop up as heads and you'd have no tails. Okay? We don't really talk about that outcome very much. Actually. But the probability of it occurring is about 8, I don't even know what it is, 8 quadruple trillionths, something like that, of a chance of it occurring. It's 7.89 times e to the negative 31. What does that mean? It's like 0.0000000000000 to the 29th power, that many zeros percent. Okay, so it's theoretically it's possible to throw 100 coins up and have all of them be heads. It's just extremely unlikely. In fact, we would probably say that there is no chance of that happening. I mean, even if you look down here, notice I've sort of cut some of the rows out. But what about the chance of getting like 70 heads and 30 tails? Well, I mean, it's pretty low too. It's 0.002%. Okay? So it's possible, but it's too 0.001%. Okay. In fact, even getting less than 40 tails, okay, is less than 1%. Okay, and if you add all these up though, or you could get 39, 38, 37 down to 0, that's of the 5% on the left-hand side of the tail. Okay. So that gives us some idea about risk. So when we look, oops. All right, so when we look at some outcome in the future, oops, we need to know if our expected value of 115 has very little variation, or if it has a lot of variation. And if it has a little variation, the appropriate interest rate or discount rate will be smaller. And if it has a lot of variation, the appropriate interest rate or discount rate would be larger. Okay. And you say, well, how much? Well, again, we'll have to see how much variation there is, and we can measure these sorts of things. All right. Let's go ahead and go back to our first problem, and maybe we'll kind of see what it means. Now, remember, there's a couple things that we've got to figure out. We're basically doing a cost benefit analysis, but we're not doing it where we think we would analyze. Normally, a lot of people like to say, hey, I'm going to spend some money today, and I want to see that if I get back more money in the future, and I analyze it at the end of the time period. So I do my analysis after it's over. Okay. In capital budgeting, because we have mutually exclusive projects, we're actually going to analyze all the projects at the beginning. Why? Because if we had 3 different projects, and one lasted for 2 years, and the other one lasted for 3, and the other one lasted for 5, then it doesn't make sense to compare A at the end of its project's life to B at the end of its project's life to C at the end of its project's life, because we won't be comparing apples to apples. But if we compare A at time period 0 and B at time period 0 and C at time period 0, now we can make the comparison between these mutually exclusive projects. Okay, so that's what we're going to do. And I'm going to do it the long way first, and then of course I'll show you the shortcut way. Okay, so we've got a project that costs $100,000 today. And as I said before, the cash flows, we'll look in a later chapter exactly how to figure out what these cash flows are. For now, they'll be given. It's going to produce $30,000 in year 1 and $40,000 in year 2 and $50,000 in year 3. Okay. Now, so far, it looks like a good project because we're spending $100,000 and we're getting back 30 plus 40 plus 50. So that's like 120,000. So that's good. But remember, we could be doing something else with our 100,000. So we want to make sure that it's earning an appropriate rate of return relative to the risk. And this discount rate, which is given, we'll figure out in a later chapter how to find it. Okay. For now, though, it will be given. So I said this whole process is a 4-part series. Okay, and we're doing part 1 right now. So how do we analyze this project if we know that 6% is the appropriate discount rate? Well, just like the answer to every question in finance, we need to find the present value of future cash flows. And when we find the present value of future cash flows, in that case, the present value of future cash flows is just the benefit that we receive. So we've got to find the present value of future cash flows. That's the benefit from the project in today's dollars. And we then compare it to the cost, and we decide whether or not if the benefits exceed the cost. So the first thing we got to figure out is what's the present value of future cash flows. No problem. We've done this many, many times. So let's go ahead and start with the first one. 30,000. 1 year from now, if the appropriate discount rate is 6%, then what is the present value of 30,000 1 year from now at 6%? Anyone get it?
28,301.89.
Let's just round it up. 28,302. Very good.
Okay.
Okay. Now we've got to find the present value of the $40,000. And the 40,000 comes 2 years from now. And there's lots of different ways to find it. Okay. And $40,000 2 years from now at 6%. Anyone get a number there?
I have 35,600.
Very good. Okay. And $50,000 3 years from now. $41,981. Okay. So let's analyze this on a cost benefit basis. In fact, the net present value is the present value of the benefits minus the upfront cost. All right. So let's look if we add all these up together. 28,302 plus 35,600 plus 41,981. I'm at 105,883. The upfront costs are 100,000. Therefore, the net present value is 5,883. Okay. So here's what we know. The project is good. If benefits exceed the cost. That's pretty easy. Okay. That will happen when? When the net present value is positive. And so if we go back, oh, not up, down. So what is the net present value of the project if the relevant discount rate is 6%? The net present value is 5,883. And should it be accepted? Yes. Now, I have sort of already shown you some shortcut methods. I'm going to show you another one in Excel in just a second. But if you want to go back and use your calculator, I think someone said NPV was on page 632. So if you go back to page 632 in your book, you can go back and review how to find the net present value. But this only works if you have a HP 10B or a BA2 plus. And it'll show you how to find net present value directly by entering the numbers into the calculator. If you have a BA, no, not BA. If you have a TI 83 plus or 84 plus or something like it, okay, you'll have to Google if you want to use that to find net present value, and we'll later find something called internal rate of return. But you'll have to use that later on to figure out what you want. Probably Google it, and there's a format that you have to plug in. It's under apps, finance, and number 7 is net present value, and number 8 is IRR on your calculator. But when you enter that in, you've then got to plug in and figure out, you plug in the cash flows and it tells you then what the net present value is. Now, since we all have different calculators, and I don't want to spend time going through each calculator, okay, the other thing you can do, is go into Excel and you'll figure out what people do in real life that's a lot easier. Okay. So if I go into Excel and put in my cash flows, and I put in cash flows, and I guess I'll put time up here to better. 0, 1, 2, 3. And my cash flows are negative 100,000, 30,000, 40,000, and 50,000. And in fact, I can give these nice fancy dollar signs if I want. I don't really care about the pennies. So here's the cash flows. Okay. I've entered them in. We can put in a discount rate. And the appropriate discount rate is 6%. And I'll type it in as 0.06. And now if I want to find the net present value in Excel, net present value formula is a little bit different. The net present value formula basically finds the present value of the benefits. All right. So if I type in equals NPV and it asks for a discount rate, you can either type in 0.06, or if you have it somewhere in your Excel spreadsheet, you can reference it. Then it's essentially going to ask you for value 1, 2, or 3. This is very important because it's not asking for value 0. It's just asking for value 1, value 2, value 3. You could type them in, or you could do like I did and highlight them as an array. When you close your parentheses, you'll notice, okay, that the present value of the benefits is 105,883. We'll get rid of the pennies, okay? So when I look at NPV, okay, NPV is basically doing those 3 calculations for me all at one time. Okay? But NPV in Excel is just the present value of the benefits. Okay? Now, if you wanted to look at, and notice that it puts it in a negative term, okay? And we know that these benefits are positive. Okay? So if I wanted to, I could switch this around. Okay? Oops. Let me try it again. Yeah. Sorry, it shouldn't have had a negative in front. If I put this in, the present value of the benefits is 105,883. So I must have had a negative in there somewhere. So all it's going to do is find the present value of the benefits. And then if you look at the upfront costs, the upfront costs were negative 100,000. Okay. And if you wanted to find the net present value, okay, it's benefits minus costs, but here my costs were negative, so I add the 2 together, and I have a net present value at 5,883 at 6%. Okay. Now, the other way to do it is you can also do it directly. If you want to do it directly, okay, most people will write it directly as equals NPV. They'll put in the discount rate, followed by a comma, enter the values for 1, 2, and 3, close the parentheses, and at the very end, add back in the year 0 cash flow. Okay. And so you can see they're basically doing it all in one step. And they're calculating the net present value and then adding back in the upfront cash flow, which is why you make the upfront cash flow negative. This is the more traditional standard way in which you see net present value in Excel done. Now, what's nice about doing things in Excel is that once we've done it in Excel, we can change something up. Okay. And what if we wanted to change the discount rate to 10%? If we change the discount rate to 10%, look what's going to happen. Okay. By changing the discount rate from 6% to 10%, okay, the present value of the benefits becomes lower. When you discount future cash flows at a higher interest rate, the cash flows are worth less today. So what we can see is that while this project is good when the interest rate is 6%, the project is not so good at a discount rate of 10%. So if it's good at 6, but it's bad at 10, okay, then there must be some break-even point. And that break-even point is the point that makes the net present value equal to 0. And that break-even point is what's known as the internal rate of return. And you can calculate the internal rate of return in your calculator, or you can calculate it in Excel very easily. In Excel, it says IRR and values. So in this case, the IRR includes all the values. So we find that the internal rate of return is around 8.9%. What does that mean? It means that this project is a good one as long as your costs or the appropriate discount rate is less than 8.9%. All right, let's see if there's any questions. Any questions on NPV or IRR? Now remember, since you're at home, if you don't like Excel, which is easy to use, and you don't want to spend time figuring out the calculator, you can use, and a lot of students like it, remember that Easy Financial app? That Easy Financial app also has IRR and net present value. In fact, it looks, oops, can't see it. But it looks something like, well, it doesn't show up. But anyway, if you go to your Easy Financial app, it just has the cash flows and the discount rate and calculate. All right. And so if you put them in, some people like that one better. Doesn't make any difference to me which one you use. Now, as a side note of caution, if we were taking this as a regular class, I would, of course, make you use your calculator, not your phone. Okay? The reason for that is when eventually you'll have testing requirements for your job. Okay? You'll need to be certified in certain things. Okay? And when you take these certification tests, they're not going to let you use Excel or your phone. Okay? You're going to have to do it by hand. And so that's why we try to encourage you to learn it with a calculator. They'll let you bring in a calculator, but it'll let you bring in an approved calculator. All right. But since we're not doing that, then I would say use whatever method you're most comfortable with. And if you want to learn more than one, I'd do that as well. Okay. Excel is going to be the one that provides the most versatility in terms of functionality when you get out in the workplace. Okay. So you can see if we look at this first question, we can find net present value by hand. And we can do all these calculations by hand, or we can just let Excel find it. Okay. And we can see then that the interest rate plays a part. Okay. And we're going to have to later figure out what the appropriate discount rate is. But remember, the appropriate discount rate is going to be a function of how likely these future cash flows that we've estimated will occur. So while we said we expect 30,000 in year 1 and 40,000 in year 2 and 50,000 in year 3, okay, depending on how much variability there is, will determine the appropriate discount rate. Okay. we didn't really mean it. Just like we don't really mean when we throw up 100 coins, we expect 50 to come up. It's just a term we use. Okay? I don't really expect 50 tails to come up. I mean, I kind of do. I really expect somewhere between 40 and 60 to come up. So I'd say I've got an expected value, but some standard deviation needs to be applied to it. Okay?
So how do we use the calculator to find the IRR exactly?
It depends what calculator you have. What calculator do you have?
Financial calculator, I have the Texas Instrument, the TI 84.
TI-84. Okay. On the TI-84, I don't remember exactly. You're going to have to look it up, but you're going to click on apps. And I think number 1 is finance. And then you're going to scroll down to the bottom. And number 8 is IRR. Did you find that?
Yes.
And when you click on that, it's going to show something that looks like this on your screen.
Yes, I found it.
Okay. I don't know the exact procedure. I'm just guessing. But I think what you're going to do is type in negative 100,000. And no, hold on. You're not going to type it in like that. You're going to type in negative 100,000 with no commas. The commas are important. Then you put a comma. Then there's going to be a bracket. And then type in 30,000, comma, 40,000, comma, 50,000. Close the bracket. And then solve, which is alpha, enter. Not 100% sure, but I think that's it. Some people, for neatness, might put a bracket at the end. Did that work? I don't have that calculator, why I don't know off the top. I'm just guessing off the top of my head.
Actually, I'm redoing it again because I think I did something wrong.
Anyone have a TI-83?
Yeah, I just tried it out. It worked for me. I got
It worked for you?
8.9.
Okay. You got 8.9%?
Yes.
Okay. All right. So if you don't know, you can just go into Google and type in IRR on a TI-84 or TI-83 plus. They're all the same. But I think that works. Okay. Everyone's calculator is going to be a little bit different, but that should work. If not, remember, Easy Financial app has IRR and NPV. Excel is the best thing to use because that's what you'll have in real life. All right. Let's look at something else as well, unless there's any more questions. All right, the other thing we're going to look at is something called a payback period. And this is really something that people use when they're trying to communicate with those that are not financially adept. So talking NPV and IRR to some people makes them nervous, okay? And they don't really understand. Instead of trying to explain it, someone might go back, let's say you're a boss and you talk to 5 people and say, hey, give me your best idea, but I need the idea to be profitable. So I want it to have a payback of say 2 years. Yeah. They can kind of understand that. Yeah. And what we'll see later on is that using the payback period can be misleading. So most people don't use it for actual analysis. They use it in conjunction with NPV and IRR. Yeah. So in this case, if we wanted to calculate the payback, all we're trying to do is figure out time. How long does it take before this project recovers the cost? So we can kind of look, after 1 year, we've recovered 30,000 in costs. So we have, doesn't like that. So we have 70,000 left to recover. After 2 years, we got another 40,000. So we're down to $30,000 left to recover. And the last year we got 50,000. So we fully recovered our money. Okay. But we want to be a little more precise than that, because really the 50,000 is very unlikely to come in once a year. Most likely money comes in every day. Okay. If it's a retail business, or it might come in monthly or semi-annually. Yeah. Most likely it's going to come in monthly, okay, or daily, okay, or every 2 weeks. Yeah. But anyway, we want to be a little more precise. So we know we fully recovered the upfront cost after 3 years. In fact, somewhere between year 2 and year 3 is when we actually fully recover it. Okay. So we look and we go to the year before full recovery, so year 2. So it's somewhere between year 2 and year 3. We look at the unrecovered cost. Or what we have left. What we have left to recover. Okay. And we divide that by the amount we receive in the full recovery year. Now this makes it seem a lot harder than it really is. Okay. But that's kind of the definition that you'll see. Okay. So really, to find the payback period, I know it's 2 years plus what I have left. I've recovered 70,000. I have 30,000 left. I'm going to get 50,000, maybe an increment, maybe it's monthly and I get like 4,250 a month or something. So it's going to take approximately 2.6 years to fully recover the upfront investment. Yeah. So again, this is non-scientific. This is sort of a rough estimate of comparing projects on how quickly they recover their costs. All right. Now we're going to run out of time, and I realize that, but I at least want to get started on the next problem. Okay. If you look at the next problem, now we've got something called mutually exclusive projects. What does that mean? Well, that means we're going to pick one of these ideas, but not both of them. Okay. So maybe we're sitting around a room and we're saying, hey, we want to expand into a new product line. Okay. We're going to do our brainstorming session and figure out what ideas you have. Okay. But we may have limited resources in terms of people and management or space. Okay. But we want to try some new ideas. And so people have come up with different ideas. Now, one of the ideas costs $250,000 to implement. And it's going to last for 4 years. And we're going to get 70,000 in year 1, 80,000 in year 2, 70,000 in year, 90,000 in year 3, and 70,000 in year 4. Okay. Now, don't worry, we'll figure out where these cash flows come from in later chapter. But I just want to point out a couple things. Project A lasts for 4 years. It may last longer, it may last shorter. What we usually call this is an economic life. And when we're evaluating something, we've got to figure out our model is only as good as the inputs we put into it. And so we're just using our best judgment. Okay. We think that this product will last for 4 years. How do we know that it will last for 4 years? We don't. Okay. But if we've been in this business a while, we can kind of guess. Hey, even the very best ideas, the very best products sometimes run their course. Okay. If you look back 10 or 15 years ago, okay, look at the best-selling phone 10 years ago or 15 years ago. Okay. It might have been something like a Motorola Razr. Okay. How many of those do you see around today? Okay. None. In fact, we don't see any Motorola phones anywhere. Yet they had 70% of the market share. Okay. Competition can cause things to fall out of favor. Okay. Technology can wipe out certain products and companies. So even though the product may last for a long time, okay, it may only have an economic life of 4 years. Okay. That's the hard part in real life, is figuring out not only what the cash flows are, but how likely they are to persist. Okay. This other idea, for whatever reason, we've given it an economic life of 5 years. It costs $400,000. But produces cash flows of $85,000, $90,000, $90,000, $120,000, and $130,000. Right. So again, you can start to see we're not going to analyze A and B based on the end of their life because they have different economic lives. But we can compare A and B by looking at net present value and internal rate of return. And we'll compare it at the beginning by looking at benefits minus costs relative to year 0, because both of these have a year 0. So we don't want to look at a cost benefit analysis at the end of the life. because we would be comparing year 4 to year 5, and that's no good. So I want you to look and focus on some of the differences. I've already told you one of the differences. You can probably figure out the other one. One costs $250,000 and one costs $400,000. Okay. That's one difference. Okay. But the one that costs $400,000 produces higher cash flows over the life of the project, and it lasts longer. The second one produces fewer cash flows, only 4 years worth of cash flows, but only costs $250,000. And so now we've got to kind of figure out, and it's pretty easy with either Excel or your financial calculator, to calculate the net present value at some discount rate. Okay. Later chapters will figure out what the appropriate discount rate is. But remember, this 70,000 was kind of like expecting 50 tails to come up. In reality, the cash flow you actually get is expected to be 70,000, but it might have some variation to it. And again, sometimes we might be evaluating mutually exclusive projects at different discount rates because of the different variations involved in the cash flows. But anyway, you can kind of see, hey, project A generates a net benefit of $12,000 and B generates a benefit of over $15,000. So if you're just using the net present value criteria, which project would you choose? Project B. And that in and of itself may be confusing, because you might be saying to yourself, hey, project B costs a lot more money. Project B costs $400,000 and only gives us $15,000 back. Okay. Project A cost us $250,000 and it only gives us $12,000 back. But again, what would you rather have at the end of the day? Remember, the $400,000 is included in parts of the cost, and the $250,000 is included. What you're looking at is, when you're finding net present value, and this is why it's better sometimes to do it by hand, you're looking at benefits minus cost. So if you think about it, this money, $250,000, if you borrowed it and didn't put up any of your own money, this project would be able to take that money, pay it all back, and leave you with the profits. And at the end of the day, would you rather have more money or less money? So if you didn't use any of your own money, people get attached when they're using your own money. But if you had borrowed the $400,000 from someone else and they charged you 7% interest, you could take the cash flows from this project, pay them back, and you get left with whatever else is left over. Okay? In other words, you're left with $15,000. Would you rather have $15,000 or $12,000? Okay? So the answer is, we'd rather have $15,000. Okay? I can kind of give you, we've got just enough time, I can kind of give you a simplified example. Suppose I gave you two choices. This is not related to the problem. X or Y. Okay? In X, you give me $1. And I give you back, say tomorrow, $1.50. Okay? So today, you give up $1. And I give you back tomorrow $1.50. Or today you can give me $10 and I'll give you back 11. Now, which one would you rather do? Would you rather pick X or Y?
X.
All right. Anyone else have an idea? X or Y? I could probably do a poll. Never done a Zoom poll. Doesn't matter. Let's see if we can do it. We don't have time. I don't know what that looks like. Okay. I don't know if it even came up. All right. And I don't know if it came up or not. Never done it before. All right. Well, maybe it came up, but put in your chat. It doesn't matter. X or Y. All right. No one answered. One person answered. You can do it mentally, I guess. All right, we're running out of time. But anyway, what would you rather have back? Okay. Well, if you gave me $1 and you got back $1.50, you're going to get back 50 cents more tomorrow than what you started with. So if we look at this in terms of NPV, most of you should have picked Y. If you pick Y, after all, you gave me 10 bucks. Tomorrow you get your 10 bucks back, plus you have $1 more than what you started with. All right. So while X looks good because on a percentage basis, it seems like you made a lot of money. Okay. At the end of the day, you got your $1 back, and the only thing extra you have is 50 cents. Okay. Whereas if you chose Y, you gave me $10. Tomorrow you got your $10 back, plus I gave you an extra $1. So would you rather have $1 more tomorrow than with what you started with today, or would you rather have 50 cents more? You'd rather have $1. Okay. And so net present value is the criteria that we use. Okay. And even though you had to put up more money with B at 7%, you got your $10 back plus more than what you started with. Okay. So with B, you had to put up 400,000, but remember the benefits are going to be 415,751. Okay. So you're going to get your 400,000 back, plus you're going to have a 7% return on that, plus you're going to get $15,751 more than what you started with in terms of today's dollars. Yeah. Just like in terms of X and Y, you should pick Y because you'll have $1 more than what you started with.
So it's not a matter of the percentage increase then?
Well, you know how all this stuff is. Okay? The answer is sort of correct, but we'll see later on that we'll modify it. Okay.
Thank you.
So right now, based on net present value, the answer would be Y. Okay. But we could change up the question slightly. Okay. If we changed up the question slightly, it might turn out X is the better answer, but we haven't changed it yet. Okay. But we'll do it next class period. Okay. So the fact that the dollar versus $10 is what's called a scaling effect. Okay. And so the size of the investment. Okay. And for some of you, you might be scared to give me $10. Okay. It's just how confident are you I'm going to give you $11 back the next day. Okay. Whereas if you gave me $1, okay, yeah, if I didn't give you back $1.50, you weren't that worried about it. Okay. But what if we had contracts? What if I signed a contract that said I'd give you back what I promised? Okay. Then you might be more likely to do what? If this money was guaranteed, okay, then you'd be willing to give me $10 if you knew with certainty you were going to get 11 back. Okay. Because if you got 11 back, you would have $1 more than what you started with. Okay. Whereas if you gave up $1, you'd only have 50 cents more than what you started with. So later on, when we talk about risk and uncertainty, we'll come back to this problem. And what we'll see is that as we compare mutually exclusive projects, we're going to not only look at NPV, but we're going to compare the IRR. Okay. And so project Y has a return of 10% and project X has a return of 50. Okay. Project X has a lot more what we call margin for error. Okay. So if something bad were to happen, okay, IRR of 50% tells us some idea that the choice X is less risky. Choice Y is a little more risky because it has a lower internal rate of return. All right. Any other questions? We're at the end of class. Like I said, I hope you have a good Easter. Okay.
Two.
Hey, someone answered all the group chat. X's. X is better. No, Y.
Brian, don't do it.
Yeah. Yeah, but it may tell me something about your risk averseness. Yeah. So, yeah. Anyway, yes, you would rather have $1 more than you started with tomorrow than you would today. All right. Anything else? Other questions? As soon as I get the test graded, I'll send them back to you. I mean, I'll post it to you, and you'll see your grade. Probably take me a day or two more. So, all right. If not, we'll see you next week and have a good Easter break.
Alrighty.